All right, guys, this video is going to be for mass, mole, mole mass, and mass conversions. We're really just going to do the mass conversions this year. So the format's going to look the same for every single problem. We're going to have the starting value, and then we're going to have three more conversion factors. We're going to start with grams, and we're going to end with grams. Now, the reason we're doing this is that for stoichiometry, we're going to be usually in a lab measuring out an amount of reactant on the left side of the reaction and then figuring out how much product we can make. And we can't measure in moles, so we need a unit we can measure, and grams is one of them. So this is going to combine the mole conversions we used last video, where you use the numbers from the balanced equation, and we're going to combine that with converting between grams and moles. So you will need a periodic table to get molar masses, or, we're working online, so you can look up the molar masses as long as you know how to do it. Okay, so like every stoichiometry problem, the first thing we need is a balanced equation. This one has all the correct formulas, but it's not balanced. We're going to put some 2's in front of NaCl to balance the chlorines, and then a 2 in front of NaNO3 to balance the nitrates and the sodiums. Then this one will be a balanced equation. With this one, our starting value is going to be 0.46 grams of sodium chloride. That's this one. Put NaCl there. And we're going to convert that to grams of PbCl2. So these are the two substances we're looking at. We're not going to worry about the PbNO3 or the NaNO3. So like all problems, we're going to start with the number given in the problem. And like we did yesterday, or whenever you watch the video, we want to write the substance in there as well, so we can better keep track. So that'll be 0.46 grams of NaCl. That's our starting value. Put some kind of placeholder under there. And then we are going to start our conversions. So what we ultimately want to do is we want to switch substances to PbCl2. In order to do that, we need to get moles. So the first thing we need to do is convert this grams to moles. So I'm going to put that underneath the fraction because we're always going to do the same thing. So we're going to do grams to moles, and the number we need for that is the molar mass. So I'm going to write the molar masses over here. So we got NaCl. So remember, we're just adding together the numbers from the periodic table. So sodium is 22.99. Chlorine is 35.45. And that gives you a number about 58.44 grams. And that's equal to 1 mole. So that's going to be our conversion factor. We're starting with grams. So grams will go on the bottom. And 1 mole of NaCl on the top. Our grams can cancel out. And now we're going to add another fraction. So some people like to stop after each step. You can do the math for this part here, get an answer, and then start with the next step as long as you do all three. It just takes up more space. Whatever you're more comfortable with. Now that we've crossed out grams and we found moles, we can do the step we learned how to do in the mole conversions from the top of page 3. So we're going to use the numbers from the reaction as our conversion to switch from the one we're starting with, NaCl, to whatever substance the problem is asking us about, which in this case is PbCl2. So moles of NaCl goes on the bottom, moles of PbCl2 goes on the top, And the numbers are whatever we have in the reaction. So for NaCl, it will be 2. PbCl2 would be 1. So what we're doing here is we're switching substances. In moles, and the numbers are the coefficients from the reaction. All right, I'm going to get a little tight on space here, but I think I'm going to make it. So we'll cross out moles of NaCl. Now we have moles of PbCl2. Our final answer wants grams. So the final thing we have to do is take this from moles and switch it back to grams. So this is going to be like what we did here in the first step after the starting value, but we're going to flip it. So we have moles. Moles will be down here. And we're going to put grams up on the top. So for PbCl2, all right, lead is 207.2. Chlorine is 35.45. So that gives you a total of 278.1 grams equal 1 mole. So 278.1 grams of PbCl2 goes on the top. We can cross out moles. And then again, just like I did up here or down here with the other ones, this last fraction is going from moles to grams and using the molar mass again. Gonna draw some little lines here. Okay, so now we are totally set up. In your calculator, you're going to multiply everything on the top. So that's going to be 0.46 times 278.1. And it's going to get divided by the numbers on the bottom. So divided by 58.44 and divided by 2. And our final answer is going to match the sig figs from the starting value. So this one has 2. We will want 2 sig figs in our answer. I forget exactly what the calculator came out with, about 1.09. Rounded to 2 sig figs, it comes out to 1.1 grams. And that's for PbCl2, but I'm running low on space. So with these problems, it can seem a little confusing, but it will be the same steps every single time. You're always going to start in grams. The first thing you want to do is add up the molar mass of whatever you start with in the problem. That's going to go in the bottom of your fraction. Switch it to moles. That's always equal to 1 mole here. In the next fraction, once you have moles, you're going to switch substances using the numbers from the reaction. And then in the last step, you're going to switch it back to grams, where you'll have grams on the top for the molar mass over 1 mole for whatever one you're looking for. Then you'll plug the numbers in your calculator and get an answer. So you're going to do this second example. And like last time, I'll give you the number answer to check your work. You're going to be submitting a picture of this one when you are done. All right. Good luck. Let me know if you have any questions.